Modern programming issues. The ground truth has changed. In the early days of programming, there was one main issue: cost of hardware. This issue drove biases and approaches used to create solutions to this problem. Time-sharing was invented to amortize the cost of a single CPU across many applications. Software was programmed mostly in a single-thread manner. Then the CPU ran multiple such threads. There was a desire to run many single-threaded CPUs, but hardware costs prevented such solutions. Computers did not have lots of memory because memory was expensive. The main concern was speed and low cost of end-user devices. This concern led towards memory sharing and an extreme emphasis on so-called efficiency. Memory sharing caused issues of thread safety. Time sharing caused programs to run more slowly since they only got a portion of the main CPU's time. Thread safety created many issues and solutions, like semaphores, Hoare monitors, use of stacks, and context switching. Time sharing caused a need for forced preemption and blocking. Blocking hid the real costs of the functional approach. Functions block when calling other functions. Synchronous functions could cause dynamic call chains of any length, knowing that the operating system would preempt them when their turn is over, saving and restoring their state using something called context switching. Operating systems need extra memory to save the state of preempted and blocked processes. Today, though, we have a set of very different issues to deal with. CPUs are cheap and abundant. Memory is cheap and abundant. Today, we need to deal with collections of tens or thousands of computers, each with private memory. Each server and each client on the internet is a separate, standalone computer. Computers are separated from one another by distances much larger than on-chip distances needed for miniaturization and speed. Issues like development time and cost can't be ignored now that the scales have tipped. Many computers are not plugged into the wall and run off of batteries. Computers are cheap today, so we can imagine using them in many more ways. Computers have shrunk due to miniaturization, enabling us to use them in various settings. Computers and their software crash more frequently due to increasing complexity. We see a trend towards offloading work to specialized devices like GPUs and FPGAs. Cooling of computers has evolved. Today's operating systems consume a lot of memory and CPU cycles. We continue to use IDEs for programming that were invented in the early days. Programming languages are just caveman IDEs for programming, based on what early hardware could do, like Gutenberg-style typesetting of grids of non-overlapping small bitmaps called characters. Our synchronous programming languages cause us to create applications that are tightly coupled, rigid meshes of clockwork gears. Modern issues require programming systems of many loosely coupled computers. Synchronous clockwork solutions are no longer appropriate for modern issues.